Hello everyone. So today's topic is gating system forecasting. So we will start with what is gating system. Then we will talk about what is the use of gating system, or you can say what is the importance of gating system in casting. So first of all, let us see what is gating system. So gating system is the, you can say, the sequence of different elements through which molten metal flows from ladle to the cavity, mold cavity. Now what is ladle? So basically the ladle is the vessel from which the molten metal is poured inside the pouring basin. So this is ladle. Okay, so from the ladle the molten metal is poured inside the pouring basin. From pouring basin the molten metal flows into the sprue. Through a sprue it reaches to the runner, and through runner it reaches to the gate, or you can say ingate, and through ingate it enters into the mold cavity. So all the elements which are coming in between this path are known as gating system. Now in gating system this riser is not included. Somewhere you will find that riser is included, somewhere riser is not included. Like here you see the molten metal, once it is mold cavity is filled, then only the metal is entering into riser. But in some cases there is a chance that first the riser is filled, then the cavity is filled. So these are so sometimes riser is included, sometimes it is not included. So nothing to worry about it. If you write, if you skip, or you can say skip the riser, still it will be correct. So let us see what are the different elements in the gating system. So first it starts with pouring basin. From pouring basin it reaches to a sprue. There is a sprue base well, okay, and then runner, then there is a runner extension, ingate, and then riser. So these are the sequence through which the molten metal enters into the gating system. Now what is the purpose of gating system design? So gating system is basically made so that we can get a casting, sound casting, or you can say defect free casting. So the whole designing of passage is very important. All the elements, either it is pouring basin, a sprue base well, whatever it is, it should be designed properly. If any shortcomings are there in the designing of these elements, then our casting will not be good, and you have to discard that casting. So now what are the things which are required, like to get defect free casting? First of all, the property, or you can say we require minimum filling time. That is very important. If the filling time, the mold cavity, if it takes a lot of time to fill that mold cavity, then molten metal, what will happen, that there is a chance that while filling only the metal will solidify in between. So that is not desirable. Okay, second is no impurities. Okay, so in the molten metal the impurities should not be mixed. We have already discussed what are the disadvantages of if the impurities are included in the molten metal. Then there should not be sand erosion, that is we should have laminar flow. Okay, so now you can understand why this sand erosion happens is because of the speed of molten metal. So let us suppose this is the cavity. This is the cavity. Okay, so we want to fill this cavity with the help of let's suppose okay, this is the pouring basin, a sprue. So through a sprue the molten metal is coming and it is filling here. Okay, so there is sometime we are saying that there should be minimum filling time. Okay, that means the speed should be more, but here it is written that there should not be sand erosion, that means the speed should be low. Then only you will get laminar flow and turbulent flow. There are two types of flow, turbulent. So if the speed is very high, then the flow will be in turbulent. Actually it will have turbulence, means there will be ripples like this. So in between the flow you will be getting this kind of ripples. So this is a turbulent flow, and it is very harmful in case if you are pouring inside this sand mold. So there should be laminar flow, like water should be flowing very smoothly. So this is laminar flow. So for this a speed should be low. Okay, so this is both are contradicting. So obviously you have to manage, okay, how much velocity you want to keep, that you have to decide. Next is no aspiration effect. What is the meaning of aspiration? We will talk about it later. No shrinkage cavity. Yes, obviously the cavity should not be there because these are the defects. Clear? Like what happens that let's suppose this metal is not solidified and the whole metal is solidified. So what will happen then? When this will solidify, then it will not get when it is shrinking, then it will not get metal to compensate the shrinkage. So what will happen? This area will remain empty because this is solid and this has become solid, and this has become solid a little bit late. Okay, so obviously here there will be some cavity and that has to be filled, but because all the other metals are solidified, then this is we will get a cavity. This is known as shrinkage cavity, and this is a defect. Clear? So there will be hollow space here. So that's why that we require proper thermal gradient. Okay, that means first this area should be cooled, then this, in this way it should go. Okay, so this is the known as thermal gradient. So that thermal gradient is required. So the gating system should be designed in such a way that we get proper thermal gradient. Above all, if all this designing is done but it is too costly to prepare, then obviously we will not go for it, because casting is low cost process. Okay, and it should be easy to implement. Okay, next is ensures enough molten metal to reach the mold cavity. This should ensure that, and casting yield should be maximized. Now what is casting yield? We will talk about it later, so that time we will discuss. Clear? Okay, so next we will go and we will talk about the different elements. So first element is pouring basin. Very important, because from here only molten metal enters into the sprue. So this is the first one. So the first point is that it acts as a reservoir from which molten metal moves smoothly into the sprue. So first is that. Okay, but that is not the function of the pouring basin. The function of the pouring basin is something else, that is to ensure laminar flow inside the sprue. There should not be turbulence. Okay, so when molten metal is falling inside the pouring basin, then it should reduce the velocity and turbulence of the molten metal. Okay, so that's what actually in the sprue directly we don't pour the molten metal. If we are pouring directly, then what will happen? Because you see the shape of this sprue, so when it will fall down, then obviously there will be very large speed of the molten metal, and that will erode the mold. Create. Second job is that any kind of impurity is there. Slag, slag, actually slag is lighter in weight. So let's suppose this is filled with molten metal and there is some slag here. So this scheme core, okay, this will stop this slag, and only the molten metal will flow inside. No slag will be entering into the sprue. Second is actually the during molten metal is filling the or going through the sprue, it should be completely filled. It should not be like going like this, or anyway it should not have any gap or any free space. I'll tell that what will happen. Like here it is written that a funnel is likely to form through which atmospheric air and slag may enter the mold cavity. So there are chances that air may enter inside the mold cavity. So it should be completely filled. There should not be any empty space. It should be completely filled. So that is ensured by pouring basin. So the pouring basin should be designed in such a way. So now let us see the designing of pouring basin. So here it is written that the main function of pouring basin is to reduce the momentum of the liquid flowing into the mold by settling first into it. Okay, so that's why the depth should be much little bit higher, and that depth is 2.5 times of diameter of the sprue opening. This is the sprue opening, so this should be more than 2.5 of the diameter. Okay, and okay, so that is important, that the depth is 2.5 times of diameter of the opening of sprue. So next the component which is a sprue, we will talk about a sprue. And what is aspiration effect? We have seen that is not desirable. So what is it? So a sprue is the vertical channel. Actually this is a vertical channel. A sprue is a vertical channel. It's always vertical. You will never find it horizontal. So a sprue is a vertical channel, and from a sprue the metal goes into runner. Okay, this is runner, and runner is a horizontal channel. Here is the sprue bell, and through a sprue bell it enters into runner, and so like that the metal flows, and this is the cavity. So runner is a horizontal channel and a sprue is a vertical channel. So it's a vertical channel through which the molten metal is brought into the potting plane, where it enters the runner and gate to reach get to ultimately reach the mold cavity. So a sprue is the job of a sprue is to take the molten metal from the pouring basin and provide it to runner. Now why it is very important to design the sprue? So what is air aspiration? We will talk. So basically that any metal, if metal is flowing freely from the top to bottom, okay, if the molten metal is flowing freely from top to bottom, what will happen? It acquires this kind of shape. We know, here the cross sectional area is more, and here it will reduce. We know that. So why this happens? So actually here, see, here the velocity is v1, here velocity is v2. Okay, now which one is higher? Obviously v2 will be higher. As the metal flows down, its velocity increases, so v2 is higher. Now according to the continuity equation, a1 v1 is equal to a2 v2. Okay, now if v2 is larger, obviously a2 should be smaller. So metal form, or you can say any fluid takes this kind of form. Clear? So what happens that if a sprue is made in this way, you see, if we make the sprue completely vertical, a cylindrical, like this, what will happen? The molten metal is flowing in this way. So here is gap you are getting. This is cavity, or you can say empty space you are getting. Now this empty space acquires negative pressure, or you can say suction pressure, and that means outside there is atmospheric pressure, okay, and sand is having permeability. Okay, so through sand the air will be sucked inside this sprue, and what will happen, that the air will mix with the molten metal, and we will get defective casting. So that is known as air aspiration, that the molten metal when moving from top of the cope to the parting plane gains in velocity, and as a consequence requires a smaller area of cross section for the same amount of metal to flow at the top. So the shape of the sprue should be like this. So it requires, because it requires lesser area at the bottom. If the sprue were to be straight cylindrical, then the metal flow would not be full at the bottom. There will be empty spaces, okay, and some low pressure area would be created around the metal in the sprue. Since the sand mold is permeable, atmospheric air would be breathed into this low pressure area, and then it will be carried to the mold cavity, and that is known as air aspiration. Clear? So you have understood what is air aspiration. So once let us go to some of the questions which are asked in the previous previous years of your university examination. So let us see that, like what kind of questions are asked from this topic. Okay, 2017-18, let us see. The question is, define aspiration effect in casting. We have already discussed what is aspiration effect. Why a sprue is made tapered in sand mold casting. So that is the question. So 5 marks question will be asked from here. Clear? So this is one question, and from this topic itself there are many other questions you will be finding, like design of riser. From the design of riser you will be getting the questions. Chills are used in casting molds. What is the correct option? So we have understood chills are used for increasing the cooling rate, means directional solidification. It helps in directional solidification. So this is the answer. Next, so these are the purpose of runner. What is the purpose of runner? Okay, then any other questions from here? Yeah, again this question was asked in 16-17, means immediately just back. So it's a very important question. What is aspiration effect? And prove that a sprue should be tapered. This proof is required. That means why, like how we get the tapered. So is there any mathematical proof of it? So we will talk about it right now. Okay, so in many other questions are there, like briefly discuss the different components of a gating system with a neat sketch. So that is a 4 marks question. So you can like solve like you have to draw the whole gating system, and you have to show different elements, and you have to define what is pouring basin, what is the use of it, what is a sprue, what is the use of it, like that. So these are the questions that can be asked from this topic. So let us go to the designing of sprue. Why the sprue's shape should be tapered, not the straight cylinder. Clear? So here is the derivation. I want to do the derivation by myself, so let me skip it. Okay, so see here, so what happens, let's suppose that this is the pouring basin and here is the sprue, and the sprue is straight cylinder. Okay, molten metal is filled here, molten metal is filled here, so molten metal will be going through this. In the beginning, let us suppose that the molten metal is coming, it's completely filled. We want that, no, that the metal should be completely filled. So let us assume first of all that the first of all shape of a sprue is straight cylinder. Okay, also metal flows through the sprue without any vacant space. We want that, we don't want that the metals when it is flowing, then there should be some space, empty spaces. It should not be, it should be completely filling the path. So let us suppose that. Now just mark some points here. This is the bottom of the sprue, which is known as let's suppose 3. This is 2 and this one is 1. Oh, sorry. This is 1. Okay. Now according to continuity equation, can we write A2 V2 is equal to A3 V3 here? Okay, now since A2 is equal to A3, इसलिए V2 is equal to V3. Now apply Bernoulli's equation in between these two. Applying Bernoulli's equation between point 2 and 3. Okay, so what will be the Bernoulli's equation? So V2 square, if you remember, just tell me. V2 square by 2g plus P2 divided by rho g and plus Z2 is equal to V3 square by 2g plus P3 divided by rho g and plus Z3. Now here let's this as datum, take it as a datum, then z3 will be 0, and what will be z2? This is the height of z2. So let us take the heights as from the pouring basin height is hp, and sprue height will be hs, and the total height will be ht. So ht is equal to hp plus hs. Okay, so z2 is basically hs. So this is 0, this one is 0. P3, acha, V3 and V2 both are same. Okay, what is P3? P3 is the atmospheric pressure. Okay, here the metal is released into the runner, so there is a pressure of atmosphere. So this is atmospheric pressure. So P3 is a gauge pressure. So when at point 3 the pressure is atmospheric, what will be the gauge pressure? That will be 0. Absolute pressure is atmospheric pressure, so gauge pressure will be, how gauge pressure is more than how much higher the pressure is from atmospheric, so that is 0 actually. Clear? So P3 is actually P absolute minus P atmospheric, but P absolute at P3 is P atmospheric, so P3 will be equal to 0. So this is also 0. Clear? So B got from here, so we got from here P2 by rho g is equal to Z2 is minus, it will come this side, so minus Hs, and we got P2 is equal to minus rho g Hs. Now you can see that pressure is negative. This is known as, so the pressure at P2, so P2 is suction pressure. What is the meaning of this? I mean, negative pressure, this will allow the air to come inside, and here is pressure 0, this is 0 and this is negative. So throughout this sprue, what is the pressure? It's negative. So you can understand that gases or air will obviously enter into the this space. So we don't want that. So what we will do, we want at least everywhere there should be atmospheric pressure, at least. If it is more, that is better, but we want at least atmospheric pressure. So let us take that part. So that is our desire. So we want at least atmospheric pressure at all points, or you can say throughout the sprue, throughout the getting system, or you can say, so we are talking simply about sprue, because here only there will be drop, rest other places there is no change in height, so obviously there will not be any drop of pressure. So a sprue, just write a sprue here, we want that. So that means here P atmospheric, this point also P atmospheric, and this point also P atmospheric. So all the places we want pressure equal. So let us apply the Bernoulli equation again. So Bernoulli equation, if we apply, so now if just take the point 2 and point 1, in between point 1 and point 2. So what will be the Bernoulli equation between points 1 and 2? So what it will be? V1 square by 2g plus P1 by rho g plus Z1 is equal to V2 square by 2g plus P2 by rho g and plus Z2. Now if we take z2 as datum, then this will be equal to 0, this will be 0. P2 and P1 all are atmospheric, gone. What is V2? V1 is 0, gone. What is Z1? Z1 is from datum to Z1, so this is considered datum right now. Here Z2 we have taken 0, so Z1 will be from Z2, it is HP, so V2 will be equal to root under 2G HP. If you put HP here, so it will go here, and V2 is equal to root under 2G HP. Similarly, if we apply Bernoulli's equation in between point 3 and point 1, between points 1 and 3, then we will get V3 is equal to root under 2G, this total height HT. Just apply this same, then we will get it. So from here we have got what we are getting. We can write V2 by V3 is equal to root under HP by HT. Now according to continuity equation, A2 V2 is equal to A3 V3, so can we write V2 by V3 is equal to V2 by V3 is equal to how much? A3 by A2, so that we will write here A3 by A2 is equal to root under HP by HT. This is an equation, just see here, this is an equation of parabola square. Y is equal to, or you can say y square is equal to 4ax. You remember the parabola equation, so this is a equation of parabola. So obviously the shape of the sprue will be parabola. This is the exact shape of a sprue, so this is parabolic, it will be clear. But now you can understand that to make the exact shape, parabolic shape is very difficult, okay, and also it is not desirable, because if you are going for casting, you see, I told that it should be economical, it should not be complex to prepare that. So we will be going for straight tapered shape, so we will be going for straight tapered. It should not be a straight cylinder, it should be straight tapered cylinder, clear. So and it has been observed, ऐसा नहीं है कि just we are going for this kind of shape, no, we are going after testing it. So it has been observed that it is giving satisfactory, it is avoiding such like aspiration effect also. It has been, see, little bit there it will be, but that is not affecting the casting. So we can go for a straight tape, it is easier to make also, okay. So that is why so this is the proof that why the shape of the sprue should be parabolic. So this equation, because this is parabolic equation, so we are getting parabola, the exact shape, ideal shape, that is, if we say, but we will get a straight tapered, okay, that is practical. So practically we are making this, so we have to prove, if this kind of questions are coming, we have to prove in this way. Okay, so today we will stop here. Okay, some of the questions you can solve which I have given in the quiz. Thank you very much.